Welcome to this FMSP online revision recording for MEI D1. In this recording we're going to be looking at critical path analysis. Now there are 5 statements on the specification for critical path analysis. The first is that you should be able to construct and use a precedence network. That's fairly standard and we'll have a look at that in a couple of exam questions. You should also be able to construct and interpret a cascade chart. So once you've got your critical path diagram, your precedent network, be able to show how one activity can follow another. And then related to that is be able to turn that into a resource histogram. And again we'll look at these two in a moment based on particular exam questions. In 4, you're asked to understand the use of alternative criteria in project optimization. In other words, if something happens to change the precedences or change the situation, be able to make an amendment on that, and finally be able to crash a network. In other words, look at what might happen to change the critical activities within your critical path diagram. But we'll go through all of these in terms of a couple of exam questions. So here's a question from June 2010. So just going through the question to begin with, you've given a table that shows the tasks have to be completed in building a stadium for a sporting event, their durations and precedences, and you're told the stadium has to be ready within 2 years. You're then told the duration in months and the predecessors of those activities. To begin with, you're asked to draw an activity on our network for these activities for 5 marks, and then on that diagram mark the early and late time for each event and give the project duration and the critical activities for 6 marks. This is fairly standard in terms of what's expected with critical path analysis. In the second part of the question, you're then asked to look at what happens when the criteria change. So here we're told that in the later stages of planning the project, task J will take 9 months to complete. However, other tasks can have their duration shortened by employing extra resources. The cost of crashing these tasks, in other words the cost of employing extra resources to complete them more quickly, you're actually told the meaning of the word crashing here, are given in the table. And so these activities, A, D, C, F and G, can be reduced by up to this many months, and the cost per month of doing that is given in this column here. So you're now asked to find the cheapest way of still completing the project within 2 years, and if the delay in task J is not discovered until it is started, how can the project be completed in time and how much extra will this cost? So we'll have a go at the first part of the question then, which is the standard critical path bit, having a look at the activity on our network and finding the early and late times and the full duration and the critical activities. So here's our precedence table. This is given in the answer, in your answer book, as how to start writing things out. So we're going to build from here. So first thing to do is look at which activities don't have any precedences, and that's A, B and C. So we're going to start A, B and C from here, and we're going to find it easier later on if we've noted how long they take. They take 4, 2 and 7 months. Now the key to drawing an activity on our critical path diagram is not to finish any of your arcs until you know you can do so. And we'll see the reason for that now. When we look at the things that follow on from A, which is D and E, we don't just want to leap in and draw these straight off A, because there might be other things that rely on A in conjunction with something else. And here we see that F relies on both A and B. So we need our network to show that D and E can start as soon as A is finished, but F needs to take into account B finishing as well. So the way to do this is we can finish activity A with a node here and space for an early and late time. We can then run D and E directly off this. Here's D and its length is 12, and here's E and its length is 5. But we also need to allow F to start as soon as A and B have finished. But we don't want it to be waiting, we don't want D and E to be waiting on B to finish. if B's already finished. So the way that we do this is we draw a dummy down from the end of A to our next node here. And this diagram now shows us that D and E can start as soon as A is finished, but this dummy here, this dotted line, shows us that this activity here, this event here, has to wait for both B and E. And when that's happened, F can then run out of that event, and F has length, F has time 7. Looking down at our next ones, we can't do G yet, that's D and J, and we haven't put J in at all. J's got some other things on it, so we're going to leave G for now, but not forgetting about it. H requires C to have finished. Is there anything else with C'ing? Well, K requires C as well, so we need a single event here at the end of C, and then we can run H and K out of this. H has length 3 and K has length 12. Now, I and J both need E, F and H to finish. There's nothing else that involves E, F and H, so we can tie E, F and H up into a single node, which we will do here. So these are all going into a single node. Now we can say I and J come off these. I'm just going to notice here that D required J, that G required D and J, so it's going to be slightly better to put J above and I below, but it's not the end of the world if you don't here. So J has got length 7, I has got length 12. Now we can do G, which requires D and J to have finished. And here's G with length 6. And then there's nothing else that needs to be done now. We've done all of our tasks, so we can just tie in all our remaining arcs into our final event node. And there's our activity on arc network completed. We'll look at the marks awarded when we finish the full question. We now want to do the early time and late time for each event. So we're moving through the network, seeing what's the earliest we can get anywhere. So starting with this node here, it starts at 0, and the only way into this is through path A, so the earliest we can get there is 4, giving ourselves time to complete A. Looking at this node here, well, we could go this way, 4 and 0, or this way 2. The earliest we can get there and have given time for everything to have completed is 4 and 0. Just 2 won't have given time for A to have completed, so the earliest we can get there is 4. The earliest we can get here is 7, because there's only one path into it. The earliest we can get into this node is either 4 and 5 is 9, or 4 and 7 is 11, or 7 and 3 is 10. Now we need to give opportunities for all of those to be completed, so it's 4 and 7 is 11. Similarly here, we need to get into this node here, so we could do 4 and 12 is 16, or 11 and 7 is 18. To allow ourselves time to do all of that, we would need 18. This last one, we could do 7 and 12 is 19, or 11 and 12 is 23, or 18 and 6 is 24, so it must be 24 to give ourselves time to complete everything. That then becomes our late time for the whole network, and we work backwards. So the only path back into this node here is 24 minus 6, so that must be 18. The paths back into here are 18 minus 7 is 11, or 24 minus 12 is 12. If we put 12 in here, it wouldn't allow us time to do that 7 and be there for 18. So it must be the smaller of those. 18 minus 7 is 11 to get back into here. The paths back into here then, we can have 11 minus 3 is 8, or 24 minus 12 is 12. So the smaller of those 8 will allow us time to get activity H completed and get here for 11. Similarly, back into here, 11 minus 7 is 7, is 4. And then back into here, 4 minus 0 is 4, or 11 minus 5 is 6, or 18 minus 12 is 6. The smallest of those was 4, and that's the latest we can get there, not run late overall. And finally, back into here, 8 minus 7 is 1, 4 minus 2 is 2, 4 minus 4 is 0, does get us back to this 0 there. So the project duration, just to finish off this part of the question, is 24 months, and we should now be able to find our critical path through the network going through activities that can't run late. So looking here, B could take a bit of time extra, C could take a bit of time extra. A is critical here. A has to be finished after 4, which takes us to here, and then again along this path here to 11, 18 and 24. So our critical path through the diagram is A, F, J, G. That is, they are critical. They cannot run late. So, in the second part of the question then, we're asked the cheapest way of completing the project within 2 years, and then if the delay in completing task J is not discovered until it started, how can the project be completed in time? So just to remind you, what's happened here is you're told that in the later stages J will actually take 9 months, and you're asked what's now the cheapest way of doing it. So this is our solution. This is straight off the mark scheme for that, and what's happened now is J's now 9 months. That's going to make that later and that later. That would make that 20 and that 26. So we need to reduce by 2. Here's the options for how we can do that. Now we could just reduce G by 2, but that would cost us 2 lots of £4 million, which is 8 million. We could alternatively reduce A and F, but the problem with reducing A or F by 2 is that if I reduced F by 2 here, this would mean I'd need to get here by 9, but 9 doesn't give me enough time to complete C and H, which is 10, and so I would have to pay to reduce C as well. So the best way to do it is to get to here by 19 and reduce G by a month, and do that by reducing one of A or F, and the cheapest one is F. So I want to reduce F by 1 month and G by 1 month, and that will cost me £6 million. In part 4, you're then asked if the delay in completing task J is not discovered until it started, how can the project be completed in time and how much extra will it cost? Well, if we don't discover until we start J that it's going to run on, our only option is to reduce G by 2 months. And if you got that correct, that will cost us £8 million. So let's take a look at how the actual marks will be awarded for this. In part 1, the 5 marks here are awarded M1 for doing an activity on ARC network, actually clearly having your activities labelled on your arcs. A1, an accuracy mark for getting D, E, H and K correct following on from A and C. So if these 4 follow on from A or C, you get an accuracy mark there. There's then an accuracy mark for this dummy and F, an accuracy mark for getting I and J correctly following on from E, F and J, and then a final accuracy mark for your last activity here of G. Assuming all of those are correct, then we can then look at how the early and late times work. So you get a method mark and an answer mark for the early and the late times. So a method mark if you appear to be getting most of your calculations correct for the early times, and if they're all correct, that's an accuracy mark. And similarly for the late times, working backwards, a method mark for evidence of correct calculations and an accuracy mark if they're all correct. And then finally just a single mark here for 24 months and the 6th mark here for getting the correct 4A, F, J and G. In this question here there are 3 marks for part 3, 1 for identifying that you're reducing F by a month, 1 for G by a month and 1 for saying it's 6 million, and then finally a method mark and an answer mark for the final one here, method mark for identifying it's reducing G, and then finally an accuracy mark for that answer there. So that's a question that looks at a standard critical path diagram, and then following on from that how we can crash it. What would happen if something affected the length of one of the activities, and taking care in thinking if that reduces, how does that impact on the others? In this question we're going to look at what's involved with drawing a critical path diagram and then finding a cascade chart based on that. So this question from January 2011 starts with a series of activities involved with making breakfast, and then asks you to show the immediate predecessors for each task, draw an activity on ARC network, perform a forward and backwards pass to find the early and late time, give the critical activities, project duration and the total float for each activity. And in part 5, this is the cascade chart element. Given that only one person is available to do these tasks, and noting that B, D and F do not require that person's attention, produce a cascade chart showing how breakfast can be prepared in the least possible time. So let's get through the precedences and the critical path diagram so we can have a look at the cascade chart. So to begin with, you're just asked to complete this based on your knowledge of what it would require to make breakfast. So for example here we can fill the kettle and switch it on without waiting for anything else to happen, but to boil the kettle we would have to have waited for activity A to have started. Similarly we can cut the bread and put it in the toaster without waiting for anything to happen, but toasting the bread again will require activity C to have been completed. We can put the eggs in the pan of water and light the gas without waiting anything, but to boil the eggs activity E must have happened, and we can put the tablecloth, cutlery and crockery on the table without waiting for anything else, but again we then need that for other things. So to make the tea and put it on the table we need the kettle to have boiled and the table to be ready, that's B and G. Similarly collect toast and put it on the table is D and G, and put eggs in cups and put on table is F and G. So what's our activity on ARC going to look like for this? Well, it's going to start the same as our previous one did, which is a node here for 0, 0. We then look down, what has no precedences? Well, A, C and E have no precedences, so here's A of length 0.5, here's C of length 0.5, and here's E of length 1 and one more G of length 2.5. We then need to go down and see what depends on any of these. Well, B can run straight off A, and A isn't used elsewhere. So we can finish. Again, we don't finish any of our arcs until we know we can. We can now finish the arc for A, put a node there, and run B off the end of that. Similarly, we can now finish the arc for C and put D there. D has length 2. I've missed off my timing for B, it's 1.5. And F of length 5 runs off E. We've then got 3 activities that rely on B and G, D and G, and F and G. Now we need to be careful with this one. We want G to have finished and then be combined with all of these separately, but we don't want H, for example, to be waiting for D to finish. So the way to complete that is finish activity G, and then we can combine it with B with a dummy. So I'm going to send a dummy up here to combine with B. Usually useful to put arrows on dummies because they can often be going in strange directions on your network. Similarly, to complete D and G, I want a second dummy here, and D and G can now complete. So this was here was for activity H, which was 0.5, and this here is for activity I, which is 0.5, and finally J required F and G, so again down here a dummy, a 0 length activity onto the end of F, and J of length 1 can run off this, and then all of these can tie down into a single final node. So that's part 2, that's our activity on arc network. We can now go through and fill in our early and late times. So the first ones are quite easy. 0 and 0.5, this must be 0.5. 0 and 0.5, this must be 0.5. 0 and 1, this must be 1. And 0 and 2.5, this must be 2.5. So they were just single activities leading into a node. Now things get a bit more complicated looking at these 3 nodes here. So to get to this value here, we could either go 0.5 and 1.5 is 2, or 2.5 and 0, so that's 2.5. Again, here we could either go 0.5 and 2 is 2.5, or 2.5, so that will be 2.5 here as well. This node here, we can do 1 and 5 is 6, or 2.5 and 0 is going to need to be 6 to allow everything to complete in time. And then the last one here, we've got 2.5 and 0.5 is 3, or 2.5 and 0.5 is 3, or 6 and 1 is 7. The earliest we can get there, allowing for everything to have completed, is 7. That's our time for the activity. We can now go back and say our late times based on everything finishing in 7 minutes. So working backwards from here, 7 back 0.5 is 6.5, there's only one route back into that. 7 minus 0.5 is 6.5, there's only one route back into that. 7 minus 1 is 6, there's only one route back into that. Now, looking at when we can work back from here, this is going to be our most complicated one. We can either do 6 minus 0, or 6.5 minus 0, or 6.5 minus 0. Well, to allow us time to get to this 6 here, we must have got to here by 6. Our next three here should be relatively straightforward. Again, there's only one route back into them. 6 minus 5 is 1. 6.5 minus 2 is 4.5. 6.5 minus 1.5 here is 5. So we can now identify our total time, just reminding ourselves of the question. In part 4, give the critical activities, project duration and the total float. So the critical activities here, we can see through that this path here has early and late times the same, and this is giving us our path through E, F, J. And the total time is 7 minutes. We're also asked to identify float. In other words, can any of these run late? Well, we can see here on this branch, either A could run 4.5 minutes late and still get there at 5. If A hadn't run late and we got it at 0.5, B could run this 4.5 minutes late. You can see the difference here. 5 minus 0 is just 5 minutes for A to complete, and it only takes half a minute. Similarly, 6.5 minus 0.5 here means there's 6 minutes for B to complete, and it only takes 1.5 minutes. So there's 4.5 there. Similarly, our float for C is 4. 4.5 minus 0, 4 minutes to complete. 4.5 minus 0.5 gives us 4 minutes to complete it in. And similarly, our float for D, 6.5 minus 0.5, 6 minutes to complete it in. It only takes 2. There's a float of 4. E is critical, as is F, as is J. Therefore, no float. G has a float of 6 minus 0, 6 minutes, 2.5 minutes to complete it in. So there's a float of 3.5 minutes. And similarly, H and I have floats of 4 minutes. So let's take a look at the cascade chart then for this. In part 5 of the question, you're told that only one person is available to do the task, and noting that B, D and F do not require that person's attention, to produce a cascade chart showing how breakfast can be prepared in the least possible time. In other words, the 7 minutes that we've already found. So here's a concise version of our critical path diagram for reference. I'm going to now draw a cascade chart to show what's happening here. Now you could do this in one go to answer the question to show how you can complete it all in 7 minutes. I'm going to do it in 2 steps. Don't worry if you've looked at these questions and see how you could write down the answer immediately. That would be fine and the mark scheme allows that. But I'm going to do this in 2 steps. I'm just going to go through my diagram and turn this into a cascade chart. Then I'm going to look at how one person could do it, given that B, D and F don't require somebody on task for those activities. So if I label my horizontal axis with time, with a square for each half minute, it looks like this. I can then fill in activity A to begin with here, taking half a minute, and then B taking 1.5 minutes after that. Similarly, I can fill in activity C here taking half a minute, and activity D following on from that takes a full 2 minutes. There's D. E takes 1 minute, and F follows on from that and takes 5 minutes all the way up to 6 minutes. So here's F. G takes 2.5 minutes. Now H has to the earliest H can start is 2.5 minutes. The earliest I can start is 2.5 minutes, and the earliest J can start is 6 minutes. So what I've got here then, at 2.5 minutes, I can start H, which takes half a minute, and I, which takes half a minute. But J has to wait until F's finished, so J goes here. So there's my cascade chart with things starting at their earliest time. I now, thinking that B, D and F, so basically these three activities don't require someone on task, need to move things around so things don't take longer than 7 minutes, but I'm only using one person to be at once. So the first thing to say is that E, F and J are our critical activities, so we're going to put them along the bottom. So here's E, same horizontal scale for time, F and J. And there's J. This is all taking 7 minutes. Now E and J require somebody, but F doesn't. So as soon as E's finished, I can then start the next person on some tasks. So I could start them on A and then B. So if they did A here and then B for 1.5 minutes, that would be fine. Once A's completed, this person could then start activity C, and when that's done, they could set D going for 2 minutes, and again, D doesn't require anyone. When C's done, they could start on G, which takes 2.5 minutes, followed by H, which takes half a minute, followed by I, and you can see here, once we get down to here, there's nobody doing anything here, and then that person can complete the task for the last 2 minutes. So let's take a look at how the marks are awarded for this question then. For the first part, there are 3 marks awarded. 1 for getting these 4 activities with no predecessors. 1 for getting the 3 activities that have a single predecessor. There's 1 mark for them, 1 mark for them, and then 1 mark for these. There are your 3 marks there. There's 3 marks for your activity on arc network, 4 for your forward and backwards passes, and then 3 marks for the critical activities, duration and total float. So these are fairly standard then. It's M1 for your activity on arc, so it's clear that you are labelling your activities on your arc. It's then an accuracy mark for this half of the diagram here, and then a final accuracy mark for this half of the diagram here. 4 marks for your forward and backward passes, so basically what's been looked for there then is M1, A1, a clear attempt at correct method for your forward pass, an accuracy mark if they're all correct, and similarly for your backwards pass, M1A1, and then 3 more marks, 1 for your critical activities, 1 for your number of minutes, and 1 for your float. Finally then, the last 3 marks here for part 5 are awarded, 1 for something that looks like an appropriate cascade chart, a clear method that it is a cascade chart. A further mark for getting your activities other than B, D or F. So here E, A, C, G, H, I, J, these activities that require somebody, none of them overlap. And then a final mark if you show that they can be completed in the 7. Now that completes these 2 questions. One thing we haven't quite looked at though is resource histograms. So I'm just going to finish. This question is now complete in terms of what was asked on the exam, but I'm just going to show you what a resource histogram would look like for this diagram here as that's the one thing from the specification we haven't covered. So I'll change colour because this isn't actually directly part of this question, but if I here look at this diagram here, for the first half a minute there's 4 people. For the next minute we're using 2 people. For this time here we're using 1 person. Then here we're using 2 people. Here we're using nobody. And here we're using 2 people. So if I wanted to do a resource histogram for my first unlevelled cascade chart, it would look like as follows. It's going to have the same horizontal axis of time. The key thing is, for the first half a minute I was using 4 people and then 2 people for the next half a minute. So for the first half of minute this axis now becomes number of people. I was using 4. For the next half a minute I was using 2. Then I used 1 all the way up to 2.5 minutes. Then I used 2 for the next half minute. Then I used nobody all the way up to 6 to 7, and I used 1 person there. That was for my unlevelled cascade chart. In terms of this levelled one here, it was basically 1 person for the whole time apart from this half minute here. So if the levelled one would look a lot more boring, it would basically look like this, up to 5.5 minutes, a gap, and then a final one here. That's a bit more boring, but obviously a lot more use, and that was for my levelled cascade chart. So as I say, that wasn't part of those exam questions, but it was the one small part of the specification that neither of those questions are covered. But now you've seen something for the whole specification. If you want to find further videos for D1 or for other units, please check out the Further Maths Support Programme website.